Hello student, today we are going to discuss about the first chapter of basic mechanical engineering as per GTU, and the chapter name is basic terminology and energy. This is a QR code of my channel and the channel name is AVM Tech Android. This is a QR code, you can scan the QR code and you can enjoy the free videos related to technical session. In the previous video, we had discussed about first topic, that is prime movers and their type. You can scan this QR code and easily you can refer that video, or you can search AVM Tech Android on the YouTube and you can enjoy this video. So today in this topic 2, we are going to discuss about different concept related to thermodynamics, or you can say the different concept related to basic mechanical engineering chapter 1. So the first topic which we have to discuss is a force. So all this concept which we have to discuss, that we learn in the standard 11th, 12th or in the 10th. So quickly we will revise that part. So first, what is the force? So force is a pull or push acting on the body that tends to change its state or rest or motion. The mathematical expression for the force F, that is equals to m into a, where m, that is a mass in the kg, and a, that is a acceleration, and the unit is Newton. So 1 Newton, that is equals to the force required to accelerate 1 kg of mass by 1 meter per second square. If we talk about the simple example, we can say that the force of gravity on a 10 kg of object, that is 10 into 9.81, that is 98.1 Newton. The second concept is of pressure. So pressure is the force exerted per unit area on the surface, and this pressure, that is equals to F by A. The unit is Newton per meter square, or the unit is Pascal. The atmospheric pressure at the sea level, that is 1.01325 into 10 power 5 Pascal, or you can say it is 1.01325 bar. What is the significance of this concept? The pressure plays a key role in the working of hydraulic system in case of IC engine and in fluid mechanics. The next is about energy. So energy is a capacity to do work. It exists in various forms that include mechanical energy, thermal energy, electrical energy, chemical energy, nuclear energy, etc. The unit is joule or kilojoule. If we talk about kinetic energy, that is energy due to the motion, and kinetic energy, that is equals to 1 half of mv square. Whereas this potential energy, that is denoted by Pe, and that is due to the position or height, that is equals to mgh. The next one is a work. So work done when a force acts on a body and causes displacement in the direction of the force. So the formula for work is F into D into cos theta, where this theta, that is angle between force and displacement. Again the unit is joule. We can say that if a force is 50 Newton moves a body 2 meter, then the work done, that is 50 into 2, that is 100 joule. If work is done by the system, it is positive, and if work is done on the system, that is negative. Means if we are supplying work to the system, it is negative, and if system is producing work, it is a positive. Next is a power. So the definition of power is the rate of doing work or rate of energy transfer. So power, that is W divided by T. So the unit is joule per second, or the unit is watt. So you can say that if 100 joule of work is done in 2 seconds, The power is 100 divided by 2, that is a 50 watt. Next is a system. This is concept related to thermodynamics. So a system is specified quantity of a matter or a region in a space chosen for the analysis, or you can say system is a region in the space upon which our attention will go first for the study. So there are different type of system. One is a closed system. So in the closed system, energy interaction is possible, mass interaction is not possible. Means energy can cross system boundary, mass cannot. The example is piston cylinder arrangement without mass transfer, or you can say pencil cell, or you can say car battery, where energy transfer is possible, mass transfer is not possible. Second case is the open system in which mass as well as energy can cross the boundary. Example is all type of turbine, pump, compressor, where mass as well as energy can cross the system boundary. And third is a isolated system where neither mass nor energy can cross the system boundary. The universe is the example of isolated system, or you can say thermos flask, in which we have to specify that assume insulation is perfect. So when insulation is perfect, in that case this thermos flask is also act as an isolated system. Next concept is a concept of heat. It is related to heat transfer. Heat is a form of energy transfer that occurs due to temperature difference between the system and surrounding. So this temperature difference is a driving potential, this delta T. This temperature difference is a driving potential for heat transfer. The unit is joule or it is a calorie. Example, when the hot object is placed in the contact with cold one, the heat will start to flow from hot to cold fluid until the thermal equilibrium is established. So what is thermal equilibrium? It is a very important concept. Thermal equilibrium means the system and surrounding, both are at same temperature. So this delta T, that is 0. When the system and surrounding are at same temperature, we can say that it is in thermal equilibrium. This is helpful when we will talk about zeroth law of thermodynamics. So this is helpful when we will talk about zeroth law of thermodynamics. Next is a temperature. So temperature is a measure of degree of hotness or coldness of a body. The common measuring scales include Celsius, Fahrenheit and Kelvin. The conversion formulas which are important for the exam include Kelvin, that is equals to degree Celsius plus 273, and degree Fahrenheit, that is 9 divided by 5 into degree Celsius plus 32. Next concept is a concept of specific heat capacity, widely known as C. So what is this? Specific heat capacity is the amount of heat required to raise the temperature of unit mass of substance through 1 degree. So Q, that is equals to mc delta T, where Q, that is heat supplied, m, that is a mass in kg, C, that is a specific heat, unit is joule or kilojoule per kilogram Kelvin, and delta T, that is a temperature difference, or that is the rise in the temperature. These two values you have to remember throughout your life. This may not be given in the exam data, but you have to solve the numerical. That is Cp of water, that is specific heat for water, is 4.187 kilojoule per kilogram Kelvin, or it is 4180 joule per kilogram Kelvin, and for air that C value is 1005 joule per kilogram Kelvin, which you have to remember. These two values are very important, which you have to remember. Next is a process. So process is the transformation of a system from one thermodynamic state to another state. So in the chapter 3 we will discuss about different processes, that is isobaric process, it is also known as a constant pressure process, isochoric process, that is a constant volume process, isothermal process, that is a constant temperature process, adiabatic process where Q is equals to 0, and polytropic process, that is PV raised to n equals to constant where n is a constant. Next is a cycle. So cycle is a series of process that return a system to its initial state. So example is Otto cycle, diesel cycle, Rankine cycle, Breton cycle. So all are cycle where the system reach to its initial state. So what is important here is in a full cycle, net work output is produced while the system returns to its original state. Means if we'll talk about the process on, you can say some diagram, you can say PV diagram. This is a PV diagram. So what you will observe, this is a state 1. Here is, you can say, state 2. So state 1 coordinates are P1, V1, T1. Here the coordinates are P2, V2, T2. So when you are shifting from state 1 to 2, it is a process. But when you are again go back to your original state, this is a cycle and it is a closed cycle. Next is the internal energy. This internal energy is a function of temperature and it is denoted by this U, delta U. So what is this internal energy U? So internal energy is the total microscopic energy stored into the system due to the kinetic and potential energy of molecule. It changes when heat is added or removed or work is done by or on the system. So when heat is supplied or heat is rejected, when you can say work is done by the system or work is done on the system. In all the 4 cases, this delta U value will vary. Next part is enthalpy. So what is enthalpy? So enthalpy is a summation of internal energy plus flow work. U, it is the internal energy, and PV, that is the flow work. So what is interpretation of this enthalpy? The unit of enthalpy is joule or kilojoule. The interpretation is enthalpy represent the energy required to create the system and make a room for it by displacing its surrounding. The unit is kilojoule per kilogram or it is joule per kilogram. It is used in the steam table and it is also used in heat exchanger design calculation. Now we have to talk about zeroth law of thermodynamics. So again here thermal equilibrium will come in a picture. So what do you mean by thermal equilibrium? When there is a no temperature difference between system and surrounding, or the system and surrounding both are at same temperature. So what is the statement for zeroth law of thermodynamics? If two systems A and B are each in thermal equilibrium with third system C, then A and B are in thermal equilibrium with each other. So this concept is used for design of thermometer. So it established the concept of temperature as a measurable and comparable property. So the zeroth law tells that when body A and body B are in thermal equilibrium with body C, then body A and B mutually are in thermal equilibrium with the body C. So this concept is helpful to design the thermometer and to measure the temperature. The first law of thermodynamics. So the first law of thermodynamics states that energy can neither be created nor be destroyed, but can only be transferred from one form to another form. So Q equals to delta U plus W, where Q is a heat, W that is a work, and delta U that is a change in internal energy. So its interpretation is like this: when the heat is added, then energy is increased or work is done. When the heat is rejected, energy decreases. So if we'll talk about some example, we can say that in the piston cylinder arrangement, if 500 kilojoule of heat is added and 200 kilojoule of work is done, then you can say change in internal energy, that is 500 minus 200, that is 300 kilojoule. So internal energy that will be increased by 300 unit. So at the end what you will observe is different concept, which you can see here. Different concepts are given, the different formulas are available here, and here you find different units are there. Like you can say, if you talk about the force, the unit for the force is Newton, and the formula that is F equals to ma. Pressure, that is F by A, unit is Pascal. Work, power, heat, temperature, then specific heat, internal energy, enthalpy, then first law and zeroth law of thermodynamics. So all this what we had discussed till now, everything is summarized in this table, and that is shown here. I hope you can understand this very easily, and this video is helpful to you. So now at the end, do not forget to subscribe this channel, like this video, as well as share this channel as well as this video to your friends, so easily they can get the knowledge with help of these free technical videos. Thank you very much.